Hello, and welcome back to Jello Devlog. In this series, I share my game development journey making a small but polished platformer with unconventional controls. Today, I want to talk to you about the environment art and the level editor. I'll show you how this one level changed throughout 3 years of development. I'll share decisions behind the art style, how the visuals evolved, and how the level editor evolved alongside them. But before we get to the level editor, I have a few exciting announcements. Not only we now have a Steam page, we also have a free demo, and anyone can play it. You can play it now if you want. I've been working full time on this game since September, and this whole time I have not been working alone. Say hi to Thomas.
Hello, I am Thomas. I am the artist working on Jello at the moment, and I'm just doing everything visual to make Jello look as good as possible.
Sweet. Together we've been working hard, and now we feel that Jello is good enough to share a tiny little piece with you.
So, if you have a controller, pick it up, go to Steam, download the demo, and jump around. Jello is really fun, and we hope you like it.
Yeah. Alrighty, let's roll it back to the level editor, the way it looked like in 2019. Remember 2019? So peaceful. I had a square grid, a square character made out of some small squares and some square particles, just to add a little bit of juice. And nothing's wrong with that. In my opinion, that is how you should start making any game. At its core, it should be fun, juicy and clear to understand, even if you use basic shapes and a few primary colors. Any visual decisions should serve the purpose of supporting and adding to the gameplay, so it's good to have the gameplay established before deciding on the visuals. That said, there have been many people who told me that the art style could stay the same and it wouldn't matter. That is just not true. The first thing people see when playing your game is the art, and that means eye candy is very important. I played around with adding some shapes in the background, or playing with the existing level editor, trying to make it look like something. It went nowhere, so reluctantly I had to do things the right way. I started looking around at nice looking platformers. Doing high quality painted or vector art seemed way too hard to do, and besides, the physics shapes of Jello are pretty blocky, so the art would have a hard time following it. Looking at pixel art games, I think it's clear. The higher the pixel count, the higher the detail needs to be. The higher the detail, the higher the effort. I tried to keep it simple, so my main visual reference was set. Celeste has nice, big, chunky pixels and a grid-like environment. I will not go as much retro, but this is a good baseline to start from. Looking at Celeste's environment as tiles, I tried to imagine how could I make it work automatically. After all, I'm a programmer and I don't want to draw them all by hand. Time to break out the pen and paper. In this fluffy banana book, along with writing down every single task and the time I had spent on it, I was planning my pixels. I drew all the tile variations needed for every possible combination of neighbors, and look at this, I was confused even trying to understand how I would make all these sprites. So I decided to simplify the system a bit. Every tile on the grid would be made out of 4 quarters. That way I could lower the amount of combinations I need to make, as each quarter has a guarantee that it will be part of a larger square. There's 13 variations in total, 8 for the outside, 1 for the inside, and 4 for inside corners. Time for a little coding! For the base, I decided to use the Unity style map system, so I don't have to worry about rendering and collision. As with every big system, I prefer to first use the tools that other people make. Assuming you can make classes with separated functions, if you really want to, it should not be that hard to swap out any third-party tools. So, I made my own tile class based off Unity's rule tile. It checks its neighbors and stores their data in a single integer using a bit mask. Then, based on the mask number, the tile decides which sprite to show. Each mask number can have several variations. I took some time to make my life easier and make a custom inspector for the tiles. That helps a lot, especially if you need to add a lot of new sprites to it. It works. Long way away from looking nice, but it is functional. For rendering the Jello character itself, there are a few simple shaders. First one creates the geometry of the cubes. To avoid holes, they all connect to the center of the character. Then, a different shader uses it as input and outputs the colors based on the neighboring pixels index. But wait, something is wrong with this image. The pixels just don't look chunky. Turns out, I made some errors when calculating the base resolution. You see, Celeste has a base resolution of the environment at 320 by 180. There's a very good reason for that. If you multiply it by 4, you get 1280 by 720. If you multiply by 6, you get 1920 by 1080. That means that scaling that image to almost common screen sizes is very straightforward, and the pixel art will stay clear. Alright, resolution fixed, now the pixels look chunky and crisp. Improving the looks of the game further was not an easy task. It took me working with a few different artists over 2 years. I asked them to make a level outline and draw over it. Working with others helped me greatly to get a fresh perspective, pinpoint the limitations of the level editor, and improve on them to make the game look better. The first issue I wanted to solve was tile repetition. I could make more sprite variations for each quarter, but because each sprite is literally 4 by 4 pixels, there's not a lot of room to work with. Looking at the concept art, it would be nice to make a separate texture, slap it on top of the tiles, and mask out the pixels where the tiles are not rendered. And that's exactly what I did. A little bit of coding later, and now our regular tiles can set secondary tiles on secondary tile maps. In this case, I have an overlay tile map. The sprites render a mask, and the tile map material draws the overlay textures based on the colors of the mask. Whoop whoop! Now that I painted in the level editor, it overlays these nice rocks. The next thing I wanted to implement was these roots, spread by the dangerous red corruption tile. They look menacing, and besides, I just love the idea of placing a red tile and it automatically corrupting the tiles nearby. It took some time and thinking, but this is roughly how it works. When placing a red tile, it propagates itself to all neighbors. That repeats a few times. There's a random chance that the propagation will not happen, so the roots look more uneven. Now there's no guarantee that these root tiles will be a corner of a bigger square. For that, I have to add a few more sprite variations to make sure the tiles can be properly displayed. Would you look at that? Isn't it nice? This is one of those features that I can play with for hours when making a level. The tile's propagation behavior is exposed in the tile editor, so in order to change it or add a new tile, I don't have to look through the code. Over time, I added lots of options here to be able to change all sorts of things. We use the same system now to have grass and snow, as well as spreading a second layer of corrupted tiles around the roots. The last big feature I want to highlight is the depth lighting. We want to make it so that the edge of the level is lit more than something deep within the tiles. I achieved this using my favorite trick, doing a little hacking. Unity is a closed sourced engine, so a lot of things are inaccessible. However, it is not the case with the new Unity render pipeline. The functionality exposed in C# is easy to understand and tweak a little bit to your needs. There are a few things you need to know if you decide to customize packages. First of all, you need a local copy of the Unity package. That way you can actually change the code within the package and make sure your teammates get the same version. Secondly, try to minimize the amount of code you change within the package. That way, when you inevitably need to update it, you will have a way easier time. I prefer to add hooks that I need within the package and keep the new important code outside of the files. You can even add an assembly definition reference to, say, the universal render pipeline, so that this code pretends like it's part of that package. So, to make the depth shadow effect, I added a subtractive light type to the pipeline. Now I can place it on tiles to create a dark spot. We still want the fall off to go in, not out, which is not possible by default. Let's make the mesh variable of the like public, copy paste some code for the fall off calculation, invert the fall off extrusion vectors, and voila! We have an inverted fall off. I can combine two lights so that one makes everything dark and the second one lights the edge. And here we go, we get the desired effect. We just need to make sure that the light doesn't weirdly intersect. Let's create a new tile map that has a simplified shape and make those tiles appear only when there's enough space for the fall off. Take the mesh from that collider, use it as a light shape, and there you have it. Of course, I simplified the process of making the level editor for this video. I skipped a few of the steps that aren't as exciting or complicated. Some of them are managing the level data and make sure it can serialize nicely, both within the Unity editor as well as in the build of the game. Updating the tiles in a smart way so that it works faster, as well as implementing a cache for faster loading. Making a selection tool to move tiles around and copy paste. Making a whole layering system for this and other things to be able to work properly. And more and more and more. To be fair with you, the process of making the level editor was not quite smooth and easy as I portrayed it here. And there's still more things to fix and improve before it is complete. In the final game we plan to have a server built in where everyone can share and rate each other's levels. Well, for now, you can already make some levels, save them locally and try them out from right within our demo. You can follow us on social media to get more updates about the game, and our Discord if you have any questions, suggestions, or if you want to share your levels. Well, I hope this was a nice video and I hope you enjoyed the demo. If you have other things you would like me to talk about in the next one, make sure to let me know in the comments. And I would really appreciate if you not just like and subscribe, but in general spread the word. It means the world for us right now.